Hey everyone, and welcome. Today, we're going to break down a really common programming task: how to generate every single possible subarray from a given array. It can look a bit tricky at first, but we're going to demystify the code and show you the logic behind it so you can totally master this skill. So, here's our game plan. First, we'll nail down exactly what a subarray is. Then, we'll reveal the code itself and break down those nested loops. After that, we'll do a step-by-step dry run to see it all happen in real time. And finally, we'll wrap up with the key takeaways that'll make this whole concept stick. All right, first things first, we've got to build a solid foundation. Before we even think about writing code to find subarrays, we need to be crystal clear on what it is we're actually looking for. Getting this right is the key to everything else. So let's dive right in. It sounds simple, right? But the little details really matter here. What actually makes something a subarray? At its core, it's actually super simple. A subarray is just a continuous, unbroken piece of an array. And that one word, continuous, that's everything. So what does continuous really mean? Well, it boils down to three simple rules. The elements have to be neighbors, sitting right next to each other in the original array. You can't change their order, and you absolutely cannot skip any elements. It's got to be a solid, connected chunk. Okay, let's make this real with an example. Imagine we have the array 1, 2, 3. To find all the subarrays, we just methodically go through it. We start at the first element, 1. From there, we can make 1. Then we can extend it to 1, 2. And then all the way to 1, 2, 3. Cool. Now we move our starting point to 2. From there, we get 2 and 2, 3. And finally, starting at 3, we just get 3. See? Each one is a perfect, continuous piece of that original array. Awesome. Now that we've got the what completely down, let's get into the how. Here is the blueprint, the code that's going to do all this work for us. And here it is. I know, seeing 3 for loops all nested together can look a little intense, but I promise there's a really simple and elegant logic to it. We're going to break it down loop by loop, and it's all going to make perfect sense. All right, let's crack this thing open and decode these loops. Each one has a very specific, dedicated job, and once you see what each one is responsible for, the entire structure is going to click. Let's begin with the outermost loop, the start loop. Its job is incredibly simple. All it does is pick a starting point. It just marches through the array one element at a time and basically says, okay, now let's find every single subarray that starts right here. Next up is the middle loop, the end loop. This one is the start loop's partner. For every starting point that the outer loop picks, this end loop takes over and says, okay, from this start, let's define every possible ending point. And that leads us to the heart of the operation, the innermost I loop. This is our worker B. Once the start and end loops have defined the boundaries of one specific subarray, this loop's only job is to go through that slice and print out every single element. Theory is great, but seeing it work is where the magic really happens. So now we're going to do a dry run. We'll trace the code's path step by step. I'm telling you, this is where it's all going to come together. We're going to use our trusty example array, 1, 2, 3, to follow the code's every move. Okay, let's trace this thing. Keep your eyes on the table. First up, the start loop sets start to 0. The end loop sets end to 0. The inner loop runs from 0 to 0 and prints the element at index 0, which is 1. The console shows 1, comma. Start is still 0. The end loop now ticks up to 1. The inner loop prints from index 0 to 1. We get 1, 2, comma. Start is still 0 and end goes to 2. The inner loop prints from 0 to 2, giving us 1, 2, 3, comma. The end loop is now finished for this start value, so a new line gets printed. Now the start loop finally moves on. Start is now 1. The end loop resets, starting again from the current start, so end is 1. We print the element at index 1, 2, comma. Start is still 1, end moves to 2. We print from index 1 to 2, which gives us 2, 3, comma. The end loop is done, so we get another new line. Finally, start moves to 2. The end loop can only be 2. We print the element at index 2 and get our last subarray, 3, comma. And just like that, the whole process is complete. As you can see from that trace, it's not random at all. It's a very clear and predictable pattern. So now that we've been in the weeds, let's zoom out and build a really simple mental model to help you remember this logic forever. So let's talk about the formatting for a second. Did you notice where the punctuation got printed? The comma gets printed right after a subarray is finished, which means it happens inside the end loop. But the new line, that only gets printed after all the subarrays for a particular starting point are done, which puts it inside the start loop. So here is our dead simple mental model. The inner I loop, it just prints the numbers. The middle end loop, that's our comma handler. And the outer start loop, it takes care of the new lines. Elements, comma, new line. That's the whole pattern right there. Here's a fantastic, maybe even an exam-friendly way to summarize the whole printing logic. This single sentence perfectly captures the exact role each loop plays in creating that clean, organized output we saw. And that brings us to one last thought, a little challenge for you. We've just mastered how to print subarrays, but this code structure is super flexible. So my question is this: how would you modify this code to find the sum of each subarray instead? Think about where you would add that summing logic. Something to chew on. Thanks so much for watching.